Um, well, thank you all for coming. The responses are really cool. I didn't expect so many people to be interested in this topic, but obviously this is all the sort of latest stuff. So we're going to be looking at running Docker containers on the Windows Server platform. How many people are familiar with Docker and or at least heard of Docker? Okay, yeah, I thought so. So we'll look at how it's going to run in the Windows platform. There's no surprises really. It's going to run pretty much like it is in the Linux world. But we're going to kind of look at some of the tooling. I'm going to talk about how you would use it in your developer workflow. We're going to run some PowerShell commands, which are the equivalent of the Docker commands, which is something you might not be aware of. It's something new in the Windows Server world. What we're not going to be doing is looking at how sort of Docker scales and the orchestration of Docker containers, how you run servers in clusters and do large-scale scheduling of containers and things like this. That's a much wider topic, but we just kind of focus on the developer workflow here. So hopefully that should clarify things. I am using beta software, right? The latest Docker tools that I have, I received them last week, a week ago. The Windows Server is Technical Preview 5, which came out about a month and a half ago as well. Before that, I've been using Technical Preview 4 for a few months quite well. So things might not work. However, I have prepared, so hopefully it shouldn't affect us too much. If at any point you feel like you're not really learning anything from the talk, feel free to pop out if you want to jump into another session. I won't feel offended. Okay. I've got my mouse in the right place. Just a little bit about myself. I have been building .NET apps for the last 10 years, right from .NET 1.0, Visual Studio 2002. I'm a full-on Microsoft web developer, Windows platform, never touched Linux in my life. And I suspect a lot of people are like that as well. And so I'm not in the cool club with all the Linux stuff and all that sort of stuff. So that's why I felt like this kind of talk for people who live in that kind of world. You know, what will it mean for you in moving to this new world of new tools and stuff. And what we're doing is we are currently in my workplace. We're not an IT company. We actually sell steel, but we're transitioning from an old IBM system to a new .NET platform. And in that, we're looking at how we can use things like this, like containers, in the delivery of our new software. Just interest. I'm an archery coach outside of here, and I also love horse riding, and I'm hoping to do some horseback archery sometime this year. So I don't know, you might spot me on the back of a horse fighting some arrows. If you do get out of the way. So the story begins back in October 2014. Microsoft announced jointly with Docker that they're going to bring the Docker tooling, the Docker ecosystem, over to the Windows Server platform. At that point, Docker could be run in Azure. So you could host a Linux box in Azure, and you could do all of the stuff that you do in the Linux world. But they made a commitment to move all of that tooling so that you could run that off Windows, and more specifically on the Windows Server platform. So we're all kind of familiar with virtualization. Virtualization is, we at some point we realize that we have this hardware sat around not really being utilized, so we can kind of emulate the hardware and expose that to different operating systems and kind of utilize the resources a little bit better. We can, we have a hypervisor and do all that funky stuff. But we're all used to sort of these products, VMware, Windows Server. You might be running things like VirtualBox on your machine, VMware Player, all that sort of stuff. But the idea of a container is the next step in virtualization, and that's how you should kind of look at that. So whereas with a virtual machine, we were emulating the hardware and kind of presenting that up to through the hypervisor to the different operating systems. Here what we're doing is we are emulating the operating system to and exposing that inside of almost like a sandboxed process. So a process which runs and looks like it's a vanilla operating system, but again, all the tricks of virtualization in just apportioning certain resources. What this means is we can run a higher density of applications on our servers. Whereas we all know, and I've been bitten by this in the past, where there's only so many virtual machines you can spin up on a shared host. Because each time you want to spin up a virtual machine, you've got to spin up the operating system and everything that comes with that. Whereas with a container host, I'm going to have one operating system and then present that operating system to each individual process. And these processes are small and really fast to boot up. And that's the real key here. All of my containers there will share the host operating system. So it's not like one container is going to run Linux and another container is going to run Windows, but they're all going to share the same base operating system. But they are really, really quick to start up. I don't know how many people have heard of the idea of immutable infrastructure. So this idea that infrastructure is now really cheap and easy to recreate, rather than creating a machine, configuring that over the lifetime of I don't know how many years, and monitoring all of the changes that are going on to that server, where it's really quick just to spin up a new server. And so why don't we just, if something goes wrong with that server, let's just scrap it. We define what that server should look like, and we just spin up another server. And that's the idea with Windows containers. Spinning up a virtual machine, I don't know, at best 10, 15, 20 seconds, 30 seconds, something like that. Spinning up a container, seconds, literally seconds. Right? If it's all, you've got the right hardware, you've got the right setup, literally seconds. Okay, so the idea, no presentation like this is complete without a picture of shipping containers. The ideas come from shipping containers, where if you think back to a time when you needed to transport goods between two locations, goods can come in all different shapes and sizes. If I have a desk like this and some chairs, and I needed to stack that on top of some transport on the back of a lorry or something, everything's going to wobble about, everything's going to be stacked on top of each other. It's all got to kind of work together. So I've got to secure that, all that sort of stuff. Well, when shipping containers came about, it took away a lot of that problem, because now we have a uniform shape and size. A shipping yard knows that this is the size of the box that I need to maintain. You can put whatever you want inside of that container. I don't care. It could be anything you want. But I'm just managing the orchestration of these containers. So moving these containers from left to right. The containers have hooks so that they can be neatly stacked on top of each other. And this is where the kind of idea of a Windows or a Docker container kind of comes from. These processes, which the host doesn't need to know what's running inside of that process, but knows how to start and stop the container, knows how to monitor logs for that container, knows how to kill the container if it doesn't respond, knows how to run it in a cluster, and so on and so forth. So it knows the boundaries of the container, and they are uniform regardless of whatever you have running inside of that. You could have a Windows service type of thing, or you could have a batch process. You could have a web application running a web server inside of that. You could have all of the cool tools, MongoDB, Redis, all these things. My Docker host doesn't care, my container host doesn't care what you have running inside of it. My responsibility is just to manage the managing of the. I'm just involved in the managing of those containers because I know there's a uniform interface to that. So you could have whatever you want going on inside the container. If you want, I don't know, you could have a party in a container. You could live in a container. People ship cars in containers. I mean, I don't know how that's actually suspended, those cars are. Wow. Hey, you could swim. If it's shipped, if it fits inside that container, if you can put it inside that process, we can ship it. We don't care what you put inside of the container. Okay. Please don't do this at home. Containers are not. It's nothing new. I mean, if we go back, I mean, this is our IT stock room, but I could have used a picture from home as well. We have this idea of using uniform interfaces, and then inside of those boxes are whatever junk that we have in there. So brings us on to Docker and all the coolness around Docker. So what is Docker? Docker is essentially a set of tooling which helps to create a container, to run a container, to maintain a registry of containers. When I was thinking about how best to explain this, I think it's best explained. I think Docker is sort of your Git tooling, your source control, and a little bit of, let's say, I don't know, your .NET framework all rolled into one. So when I say Git tooling, it manages like a repository of containers, and it maintains a history of the changes on the container. It will you can commit, and you can pull and push from a central repository the definitions of these containers, so that I can share the definition of these containers with other people, either within my own organization or with the public. And Docker maintains a public registry. So the analogy we get is like that. We can also commit changes. So if I make a change to the container, I can save that back and then version control that. It's like your source code repository, so it will push all of that stuff back into a central repository which you can maintain on your own servers or on a public server. It's a framework, like a .NET framework, so it will run your containers as well. So wherever you have a Docker host configured, you could run that container, so it could run on multiple machines. However, a Windows container will not run, a Windows container defined in Windows, you can't run that on a Linux host. They're not that interoperable. Windows containers defined in Windows will only run on Windows containers. Linux containers defined in Linux will only run on a Linux host, for example. You can run a Linux host on Windows, but like I'm going to do as a demo, but you can do that. So what gets, how does Docker do this? So Docker, you have a what we call a container host, or I might use the word Docker host. That will have the Docker engine installed on that. That's now, once that's on there, and we'll look at what the different components of a Docker engine is, it will then allow you to then run your containers. And so then the idea is here, you've got your, each column here is a container, and you can spin up multiple containers there. How it does this is through a couple of pieces of technology, and this is kind of like borrowed from Linux world. So container support in Linux goes back a long, long, long way. but it wasn't always called containers. Google have been running containers for over 10 years. So this isn't something new. What's new here is it's being brought to the Windows platform. And the changes that have been made in, we'll talk about the changes in the Windows platform, but essentially there's two technologies going on here. They're called namespaces and control groups. Namespaces present to the container a view of the files that it can see. And so it just basically presents a vanilla operating system. So it will see program files, it will see the user's directory, it will see the Windows directory, and so on and so forth. The container doesn't actually have a copy of those files. The Docker engine is actually presenting basically a view of those files. Control groups is the other bit of technology here, which is presenting the processes. Control groups are the resources that the container can access. It's not actually physically provision those and mark them off as in, like, only this container can use the 10 megs of RAM or something. However, it's just virtualizing that and presenting that to the container. So namespaces and control groups, what you can see and the resources that are available to that. So that when I run some of my commands to see how much memory I have left, then the control groups feature will go in and show that. Docker adds another little. So Docker adds a little feature here to containers, then which they call copy on write storage. So if you then start to make any changes inside of your container, that's when Docker will now start to keep a copy of certain files for that particular container. So the footprint is really lightweight. It will only consume memory where it's where you've actually made any customization. So the app that you deploy, maybe, I don't know, the host file that you might change inside of the Windows container, it will then keep its own copy there at that point. And that's where it kind of then starts to drift away from the host operating system. So what does a Docker engine look like? Docker engine is made up of sort of these three main, so the Docker ecosystem kind of make up these three things. The Docker client, which is a command line tool, much like if you're used to using Git and all of the new .NET tools as well for ASP.NET Core. You're going to be doing Docker build, Docker pull, Docker run in the same way where you do like a git commit, git pull, push, all that sort of stuff. So you have a command line tool. That command line tool you can install on your Windows machine. It can live on your machine. And it can run on Linux and what have you. And you could point that at any Docker host. So it could be a Linux host, it could be a Windows host. You have a Docker host. My mouse has stopped responding. So you have a Docker host, which has a Docker, you'll see this, the Docker daemon. The Docker daemon is the actual engine that actually runs and responds to the commands of the Docker host, of the Docker client, sorry. The daemon is installed on the server, and it's the thing that provisions containers and maintains the images, the base images for containers. Those base images you can then pull down from a central registry, and at the moment that's called Docker Hub. And so in Docker Hub you'll find anybody can push and pull images from that Docker Hub. So that's where you'll get some sort of like the official images for things like Redis, for MongoDB. SQL Server is not in there yet, but with the recent announcement that SQL will run on Linux, I'm sure that will come. Nginx, if you're using that sort of web server, lots of other things. At the moment, in the Windows Server world, the only people who've really contributed anything to it is Microsoft. So there's a handful of containers that you can pull down to run in your Windows Server box, but there's not many at the moment. But that will increase as we get closer to a proper release of these things. So what does Windows Server? What's the Windows Server story here? So when Microsoft announced that they'll support containers in Windows, what did they actually do? They had the Windows team actually had to make some quite not drastic changes, but they had to make some changes down at the Windows kernel level. I'm not too familiar with that, but I didn't dive too much into that. But what they ended up with is Windows Server 2016, which is currently out in Technical Preview 5, and will support and has a feature just like you have an IAS feature, a DNS feature on a Windows server. You have a containers feature. A containers feature, once you install that, you'll get the container support. Now, there's two flavors of Windows Server that are really relevant for us: Windows Server Core and Windows Server Nano. Windows Server Core is your next version of Windows Server, but without the GUI, so what we call like a headless server. And you can do that, I think, now in Windows Server 2014. Anyway, you could install it without a GUI. So you can remote into it, but all you see is the command line prompt, and you do everything from that, or PowerShell, whichever one it is. Windows Server Nano is the same sort of thing. However, Windows Server Nano is the thing where there's a lot of people talking about, the support for containers. Windows Server Nano, basically, what they did was they took Windows Server and they stripped out all the stuff that is non-essential for Windows Server to run as a web server. So what they've done is they've taken lots of stuff out, reduced the footprint. I think if you download Windows Server, like the full thing now, it's like gigabytes and stuff. Windows Server Nano, I think you can download it in about 400 megabytes. So the footprint of the server itself, the whole server, is only 400 megabytes. That's quite an achievement from something that's started off as like 3-4 gigabytes, right? That's fantastic. It's 20 times. These are stats from all of the marketing stuff and the webinars and stuff. 20 times smaller. 80 because they've reduced the footprint of the server. There is 80% fewer reboots that you will require. That's a massive improvement. Because of that as well, 90% fewer critical bulletins. So there isn't the footprint for some of the security vulnerabilities that they've had in recent times. And I think at the moment, you can use it to do these things. So you can use it to run as a container host, a DNS server, a file server, and a web server, an IAS server. That's all you can use Windows Server Nano for. Sorry? Hyper-V as well. Yeah. Hyper-V, yeah. We'll go on to the next slide when we get to. So this is really designed to kind of run in cloud data centers, and that's the real driving force behind this. However, in your own enterprise, if that's a situation that you're in, that's what we're in. This becomes a real game changer in terms of, storage isn't really an issue nowadays anyway, but to spin up these lightweight operating systems that have almost like a single purpose is really attractive for even in an enterprise environment. So everybody gets containers. So we've got Linux and Windows now both. We've got containers. Now we've got two types of containers in Windows. We've got what's called Windows Server containers and Hyper-V containers. And I had another slide where I put in the matrix of what's possible and what. All that you kind of really need to know is that Windows Server containers will run on Windows Server Core, and the only place you can run Hyper-V containers is on the Windows Server Nano, essentially. The difference here is that the Hyper-V container is set up slightly differently. The image makes it look a little bit like a virtual machine, which it kind of like is. So when we provision a Hyper-V container, it's still using all the same tooling. However, what happens here is that memory and some resources are physically allocated to that container. And that's not the case with a Windows Server container. What the real sort of thinking behind this is, well, it's possible, although I've not done it, it's possible to potentially break out of a container, of a process breaking out of a container. that could be down to a flaw in the way that the containers are implemented. I've not seen anybody do this at the moment. The Windows server platform with this stuff is very, very new. So there's not, there's only a handful of people who are actually, using this right now. But it is potentially possible to break out of that process, which means that you could affect other processes in other containers. And so with that thinking, they're thinking, well, let's make a more bolstered, a better security model where you might have a process that you don't trust, and you want to run that inside of a thingy process. So you could potentially, I don't know, you might have a third-party app that you want to run inside of a container. You don't control that app. You've been supplied by somebody else. It could be like in our situation, we're looking at maybe a third-party system like a HR system. We could just deploy that into that container. It runs in IIS, and I can just run, and I know that it's going to be isolated. It's not going to affect any other container. It's not going to be able to break out of that container. It's not going to be able to sort of like jailbreak the container. So in the Hyper-V container, you're going to get dedicated kernel. You're going to get dedicated resources, CPU, memory, I/O. And it kind of looks like a VM, but it is still a container and running in the container. With this model, it means that you won't be able to get as many containers running on a host as you would do with a Windows Server container. So that's where some of the difference kind of lies. If it's just applications you're building yourselves, just stick with Windows Server containers. Any third-party applications, stick them in a Hyper-V container. This model will probably be interesting. Actually, I'll talk about that later on in Windows 10. So let's look at a couple of demos. Now, I'm going to a couple of demos. I'm just going to just run through an image like this. So what we're going to start off with is the, Docker images. Docker images will show us all of the base images that are installed on the machine. A Docker search will show us all of the images that are available in the registry now. So these are the ones that Microsoft have supplied so far. So you can see we've got .NET 3.5 in there. We've got an IIS machine, a machine that's set up as IIS. I'm going to use a Docker run command to go and run that container. And basically, I specify the name of a container, and then let's just bring up here. So I specify the name I want to give the container and the base image that I'm going to use, and then the process I want to run inside of that container. Now here, what's happened here is I've said use this base image, but that base image doesn't actually exist because Windows Server Core is, I'm using a latest tag, and it doesn't have a latest tag, it has this tag here. So now I need to redefine the base image and say it's Windows Server Core 10.0.14.1430 and 1000. So that's now going to run. Now you can see here Windows Server Core, the base size of that container is like nearly 10 gigabytes. That is, that's quite a lot. If it was a nano server, it would be a few hundred megabytes. I haven't got any nano server demos because nano server is a little bit tricky to set up right now. But so they're all Windows Server Core demos right now. So here it's just spinning up. And I will be honest, this I did say they were quick to start up, but I think this is some of the issues that are currently in the technical preview software that you might potentially face right now, and possibly other machine configuration. So I'm actually in the server here. I've done a host name, so that Docker's actually given the container that name there. If I do an ls, I can see, remember I talked about the namespace feature, so it's going to show me these are the directories inside of that container. I went into the iNet pub just to see what was in there, because I haven't at the moment installed IIS onto this container, and that's what I'm actually about to do here. So wget is a command that you can run in PowerShell just to make it's like a curl request, you can just do a web request. So just to prove to you there's no local host running on that machine. And so now these are just PowerShell commands I'm running inside of that container. Now you can see the color scheme is kind of messed up a little bit here in PowerShell. That's again, I think, a container thing right now. So it's currently installing IIS. Without IIS. I've just done a localhost request now, and that's just come back with the headers and the response. So that's IIS installed on that. I'll do an exit to exit out of the container now. So I'm actually running that container as an interactive session. So I start up the container, and then Docker ports me into the container, so I can start running commands inside of that container. So once I exit responds, and gets me out of the container. Now I am out of that container, so I've done an ls for a sanity check to see where I am, because it doesn't tell me whether I'm in the host or I'm in the container. So I can see I'm back in the host again now. So what I'll do now is I'll do a Docker commit, which is like a save. So I've made some changes to that container by installing IIS. So now I want to save those changes to my local repository, to my local repository. So I'll do a Docker commit. But before that, I need to know the name of I need to just have a look at some of the information about the container. So I do Docker PS, which shows me all of the running containers. And Docker PS -a will show me any containers that I've stopped. So there you'll see ports that have been defined, the image, and then down here, first container was the name I gave it. It told me that the command I ran when I ran the container was PowerShell, and it created 4 minutes ago. So I'll commit. I'll say commit this container and give it this name, and I've called it local/IIS. I do a Docker images, and there you can see now I've got that committed to my library. So now I can run new containers based on this new image. So I've just made some changes, committed that to the repository. Now I can use this as a base image to go and do some other stuff. So I will now then, I'm actually removing that container from the library, and you can see that's gone. And then just like Git, I've got a Docker history command. So that will just show me like my repository history. At the moment, it's not showing much. Some of the other demos I've got will show a little bit more. You can see the change that I made to install IIS was just under 140 megabytes. And let's have a look at the history on the official container image. And that, for some reason, comes up empty, which it wasn't doing before, but that's that. So that's a container running there. Next one is, I will switch to some live demos as well, but it's just I want to get these ones out of the way. So this one is a PowerShell equivalent of that same demo. Now the team have built a set of PowerShell commands which mimic the same thing. So the first command that I ran there was get command module containers. This shows me all of the PowerShell commands that I have to manage containers in PowerShell. So this is almost like a parallel library way of managing containers. So we'll get the same sort of thing. Get container image will show me the base images that I have. So I've got a base image of Windows Server Core on there. There's a little bit more involvement in getting a container set up. So I have to look at the networking. I have to look at some of the networking properties of that machine I'm running on. But I'm going to spin up a new container by doing a new container PowerShell command. Tell it the container image, and there we go. So we've got a new container. It's not started yet. It's currently off. I can now get my container in a variable because I'm going to reuse that. And then let's start up that container in PowerShell. Okay, so there my container is now running. Now the Windows PowerShell Weve getting into that container is just using your enter PS session, which is like a remote PowerShell session. And I actually think that this way of doing it is a little bit better than the way that sort of the Docker tooling presents logging into a container, because you'll see here I'll get the container name on the left-hand side. So now I can see that I'm actually logged into my container. And again, I'm going to do the same sort of things. I've seen the host name. Docker's given that name to that machine. LS, again. I could do, if I was brave enough, I could remove all of those directories inside of that, which you wouldn't ever do on your machine. But I could remove all of that, come out of my container, delete the image, and restart it. It won't affect the base image. So this is kind of like that right on the third feature I mentioned that Docker gives you, where only those changes are affected the container. Here I've just listed all the processes running in the container, although the container thinks it's running in that container, but it's the way that the container platform is presenting that to this environment, to this container. Here I'm not actually running Docker to provision any of this. So this is stuff that they built through PowerShell in Windows Server to be able to do this. Now, I had some problems here, and I don't think I'm going to be able to install IIS on this machine as well. But essentially, I do the same sort of thing. I would install IIS using the install feature. This was working in TP4, Technical Preview 4, but I don't know, there was some reason why that's not working, and I haven't investigated that yet. So we will stop it there, and then let's have a look at okay, so let's have a look at running a little application now then. So this is on my local machine, and what I'm doing here is I'm actually going to run this against a Linux container this time. Okay, I'm doing that because the Windows container and this bit is still a little bit shaky in getting all of it working, and there's some ports that we need to set up and all that sort of stuff. So I want to kind of avoid that, and it's just going to take a little bit of time. So first of all, let's if I just switch. No, that should be all right, actually. So let's see where I am. So I'm going to use the Yeoman generator. I don't know if you guys have seen this, but hello. Scott Rocks. So we're going to create a new ASP.NET Core application using the Yeoman generator. That's a node tool that you can download and install. And it goes and basically just scaffolds a website for you. It's like doing file new in Windows in Visual Studio. So inside of here, I've got my application. Let's have a look at the let's have a look at this file now. So this is this is the next thing that Docker tooling gives you. You have something called a Docker file. A Docker file defines how you should build a container. So I showed you kind of the manual way of starting a container, going in, configuring IIS, and all that sort of stuff. That's cool, but that's not the way you should be doing it. Right? You should be doing it through a Docker file. A Docker file is something that gets committed into your source code repository. Docker knows how to build an image based on this. And if we have a look at this one, what this Docker file is doing, it's saying, well, from this base image, okay, so this could be anything. This could be a base image that you've defined in your own repository. Run a load of commands. So this is doing some apt-get update. These are Linux commands. Copy my application from the current directory, which is this here, into an apps directory, and then run a DNU restore, and that's a ASP.NET Core function to restore all of the packages for that application. What's important here is it's saying from that container, and this is the real value that Docker gives you here, from that container expose port 5000. because by default the applications that run port 5000, if you run an ASP.NET Core application, you can run it on any port you want. But that container is now going to expose port 5000, and then I'm going to tell when that container starts. This is what I want you to do. I want you to run dx against the project.json and run the web command, so that it will then start up the web server. And so that's the same as me doing DNU. That might not be a good idea because of the internet connection here. Let's do DNU restore. So now I'm going to go and download the internet just to run a basic application. No problem. All of my Docker containers could have the same port exposed. It's how I'm going to map that port out to the outside world, and I'll show you that in a command when I run that. So I'm going to map a host port to a Docker port, and that's where you would then do the mapping. So, that was quick because I've got some of them packages cached. So now I'm going to do a Docker Docker build -t. I'm going to call it DDD Scott Rocks version 0.1 and build that from. I'm just going to quickly check my commands here. Yeah, okay. And build that from the current directory there. So that's a Docker command that will then go and read that Docker, the Docker file, and now it's going to go and spin up a container based on the base image, go and deploy my application into the container, and then do the DNU restore and set up the application in line with my commands that I ran there. So this could take a little bit of a while because it's going to download all of these packages and all that sort of stuff. So, like any good Blue Peter presentation, I have one prepared earlier. So let's do Docker images. Can everybody see that okay? I don't need to make it bigger, do I? Right. So I have some ones that I prepared earlier here, where I just did the same thing. We've got 2 hours ago, and you can see the base. You can see the size of those images are now 1.4 gigabytes. It seems a lot, because all I did was took the base image, which was around about there, 815 megabytes now. But this is a Linux box, and then just adding that one application, a basic application, is like almost doubled it. This is a bit disappointing. It's that big, but that's the world we live in these. So now, if I do a Docker run. Right, Docker run minus. I won't give it a name. My mind's going a bit blank here. Right, sorry, yeah, that's what I need to do. So minus P, I'm going to go. Right, so now I'm saying on my container host, my machine here, I'm going to map the port 8080 to port 5000 on my container. The container I'm going to use is build-ddd, ddd Scott version 1.1. And I'm going to also add the -d to that so that it'll just run in the background. And I think that should be it. So that's, if I now do a Docker PS, which will show me all of my running containers, I can see here that this is my container here, based on the build DDD Scott 1.1 image. And Docker does this thing where if you don't give the container a name, it gives it a name itself. And it has some really interesting names that it gives it. So insane buffer. and you could see, honestly I didn't name that. That's the one that's restoring at the moment, which might take a little while. The one it's built in from the Docker file. So now that that's started, I can do Docker 8080, which is, and hopefully, there we go. So that is a container running the Yeoman-generated ASP.NET Core application, RC1, I think it is. So that's running in a container. So what I can do, Docker will now show me. Let's have a look at the logs for that container. So insane. There we go. So if you've run a ASP.NET Core application, you know that the command line then prints out, by default, prints out all of the requests that you're making. So if I make another request in the browser here, this will not update automatically because I've got to go and pull it out. But these are all of the commands that have been output as a result of the command that's running in the container. So again, this is sort of beyond the scope of this talk, but these logs are really, really important, because what you want to be doing is you want to be shipping these logs out of these containers into some sort of central repository, log repository, and then running some analysis on that, to understand what's going on. What you don't want to be doing is storing these logs inside of the container. As much as you can, avoid saving any data inside of that container, because the container, the idea is that it should be like this immutable infrastructure, so where you can, if you destroy that container, you can spin up another one. You don't want to you don't want to stop yourself from destroying that container because it's got some valuable data on that container. You want to be able to ship that off. So what you can do is you can mount external drives and things like that, so you can store your own, maybe, I don't know, log4net logs to file or something like that to your own mounted container. And so that's essentially one of these. So you want to get these logs off that server. Docker, I can show you a couple of other commands. I can do a Docker inspect on that container. That's going to show me the definition of that container now as it's running. No surprise, it's a JSON command. You can see that's the IP address of that container, but I don't really care about it. I don't need to mess around with that. I don't know what can we show you inside here. It's telling me it's running on Ubuntu because this is a Linux one. But this same experience, what I've just demonstrated to you here right now, will be the same experience for Windows Server Container as well. So there should be no difference. All of the Docker commands are coming across to Windows, and there are actually, most of them are actually there and work fairly well. But there's a few quirks at the moment with them. So that's that. Now, very quickly, let's have a look at the Visual Studio side of things. So we've got 10 minutes, running a little bit short on time. So inside of Visual Studio, we've got a tooling for Docker containers. At the moment, you have to install it as a separate add-in. And what that gives you is, if you, let's go and create a new web application. So this Docker tooling only works at the moment for ASP.NET 5 or ASP.NET Core applications, the new web applications at the moment, which you get from there, the ASP.NET 5 templates, which is going to be updated to Core. I click OK. And what I get is, no, I don't want to use Azure. What I get here now is I get a option here where I go add Docker support. And I add Docker support, and now I get some of those Docker files. So I get Docker file, which tells Docker how to build. So this one's a little bit more complicated now. This is out of the box, so this is going to be telling us to use DNX watch for any changes that we make. So what we get is we get Docker files. We get a PowerShell script which wraps Docker and running those containers again, which I don't think is quite right, but it just wraps a few Visual Studio commands inside of that, and that's how Visual Studio then runs this as a container. And I've got some properties that I can set here. Interestingly, what I get is up here, you'll notice now I get a Docker command up here. So when it's set to Docker and I hit F5 now, what it's going to do is it's going to go and build that Docker image. So it's going to use the file, go and do Docker build, and stick this application inside of that container, spin the container, press F5, and away it goes. Now I'm going to hit F5. Problem here is it's going to go and run, it's going to do a whole package restore and all that sort of stuff inside the container. That's going to take a while. I can show you it doing it, but I'm going to just skip that bit there. So here is the same sort of output that we got when we were building by the command line, but it's all just being displayed here in the output window. So what that did was, if I go to here, Docker images, and these were the images I built last night with that same thing. So I can now run that command, and it would then run my application deployed into that. So that's the sort of the Visual Studio side of things right now. This tooling is still quite raw. We can point this at a different Docker host as well by changing the Docker props up here. However, there's no guarantee that these tools are going to stay like this. They're still changing, and they're still in a bit of flux right now. But the experience here, you'll be doing F5. It'll go and do the build. See where that's gone now. Yeah, it's still package restoring or something, or installing. And then deliver that into your container and ready for you to build. Now, personally, I don't think this experience is good right now, because if I have to wait for this long for stuff to fire up in a container, I'm not going to do that. I'm just going to run it on my local machine. And so they're still, the team are still sort of accepting, taking ideas from the community to kind of understand how best to use this. Personally, I feel like I feel more comfortable going back to the command line tools and then just spinning up my containers through that. It just seems a nicer experience. And that's that. So let's just go back to the presentation, just because we're going to run out of time. And let's just quickly run through some of this stuff. So the Visual Studio tooling you can get from this page, and I'll have links at the end. But most importantly, I think that this is what your kind of development workflow will kind of look like. You'll be writing code and committing, just as you're doing right now, and you'll be making changes to that Docker file. You can use them command line tools or use the F5 tool like I just showed you to spin up your application inside of the container to test to see if the application is running okay inside of that container. You shouldn't be making any changes to that container yourself. You shouldn't be like remoting into using the remote PowerShell commands or any of the Docker commands to go into that container and make any of the changes. You should be making changes to your Docker file. So if there's any environment variables, avoid putting any sensitive information inside of your config files, and push that in via environment variables, which is the way that the new ASP.NET Core stuff is moving towards. And there'll be a way of having secrets inside of your environment variables, so they won't be exposed. That's it. Just like you must have all heard of the stories on Git where people have left passwords and things like that in their Git histories, and so you can do the same thing with this. If you deploy your application in there, it's got your passwords in there. It's anybody who's got access to the history and that, they can go in and go and find that. So don't deploy the sensitive information into those. But what you will do is you'll push them into it as environment variables, and in that Docker file you can define your environment variables, so you can set them up, and then your operations guys or whatever, they can when you do your Docker runs, you can push in your environment variables at that time. So if anybody's used the release management tool, it's a little bit like the variables you configure in your release management for your different stages and so on. You'll be you write your code and commit. Your build server will go and build that Docker image to check to see if that Docker image builds, and build that Docker image and has that in a repository. At that point, you can run some integration tests against that Docker image to see if your application now looks okay and works, as expected. And then build service then push that Docker image back to your registry. Now that image is your application is deployed into that Docker image, that base image is now ready to deploy into whatever environment you want, whether it's QA, staging, production. That's another set of tooling, wherever your release management process is then. And that's the kind of workflow that I think that you will be using to manage this. So in terms of the tooling, Docker have got a new version of their Windows tooling, and that's a beta program. You can sign up for that, and then they're releasing around about after a month or so, you get access to those tools. Them tools are really, really cool, and they're a breeze to set up. Right now, if you want to run Docker tooling on your machine, you have to install this thing called Docker Toolbox, which installs VirtualBox and a load of other stuff, and which means you can't run it side by side with Hyper-V because hypervisor gets in the way and all that sort of stuff. Docker Toolbox does install a few things. So we talked about the Docker engine. Kitematic. Let's show you Kitematic actually. I've got Kitematic running here. So Kitematic is your GitHub for Windows. And it looks like this. Oh, sorry. That's Kitematic. It's your GitHub for Windows. So over there on the left-hand side, it's showing me my containers that I have running. But if you're not comfortable using the command line, you can use this tool to go and pull down base images from the repository, manage your own containers. I think I could start and stop containers from there as well. I can see the logs from the containers. It's a nice tool, but at the moment, it's like I said, it's on a bit of flux at the moment. So there's a bit of setup that you need to do to get it working. Docker registry, Docker compose. Now, your application, a lot of demos, it usually shows just one application, but how many of us are ever working with one application? We're not. So it's a web application with some web services, maybe some batch jobs, all that sort of thing. So you use something called Docker Compose. Docker Compose defines maybe your logical application. So you can orchestrate, my application actually looks like a web service running in a container, a web application running in a container, the connect the provider and say, here, just run my container. I don't care what hardware you're running on, where it runs, and so on. The Hyper-V support is a little bit hit and miss, so I'm not sure that that's quite right on the top there. But essentially, we've got 3 features there in Visual Studio that's coming up. Debugging is the next one that we're looking for, and I'm out of time now. So I think finally, container support's actually coming to Windows 10 as well. So that'll be really interesting, being able to run containers inside of your own application. All right, there's a lot of links on there, and that's you will be able to get the slides by this afternoon. Thank you all for coming. Please leave some feedback at the end of the program. I'm not trying to influence you in any way, but there's some lovely Docker stickers here if you want to add them to your laptop. The kind folks at Docker allowed us to send these over in time for this conference, so help yourselves. All right, thank you very much, guys. Used to sort of these products, VMware, Windows Server. You might be running things like VirtualBox on your machine, VMware Player, all that sort of stuff. But the idea of a container is the next step in virtualization, and that's how you should kind of look at that. So whereas with a virtual machine, we were emulating the hardware and kind of presenting that up to through the hypervisor to the different operating systems. Here what we're doing is we are emulating the operating system to and exposing that inside of almost like a sandboxed process. So a process which runs and looks like it's a vanilla operating system, but again, all the tricks of virtualization in just apportioning certain resources. What this means is we can run a higher density of applications on our servers. Whereas we all know, and I've been bitten by this in the past, where there's only so many virtual machines you can spin up on a shared host. Because each time you want to spin up a virtual machine, you've got to spin up the operating system and everything that comes with that. Whereas with a container host, I'm going to have one operating system and then present that operating system to each individual. Well, thank you all for coming. The responses are really cool. I didn't expect so many people to be interested in this topic, but obviously this is all the sort of latest stuff. So we're going to be looking at running Docker containers on the Windows Server platform. How many people are familiar with Docker and or at least heard of Docker? Okay, yeah, I thought so. So we'll look at how it's going to run in the Windows platform. There's no surprises really. It's going to run pretty much like it is in the Linux world. But we're going to kind of look at some of the tooling. I'm going to talk about how you would use it in your developer workflow. We're going to run some PowerShell commands, which are the equivalent of the Docker commands, which is something you might not be aware of. It's something new in the Windows Server world. What we're not going to be doing is looking at how sort of Docker scales and the orchestration of Docker containers, how you run servers in clusters and do large-scale scheduling of containers and things like this. That's a much wider topic, but we just kind of focus on the developer workflow here. So hopefully that should clarify things. I am using beta software, right? The latest Docker tools that I have, I received them last week. Just interest. I'm an archery coach outside of here, and I also love horse riding, and I'm hoping to do some horseback archery sometime this year. So I don't know, you might spot me on the back of a horse fighting some arrows. If you do get out of the way. So the story begins back in October 2014. Microsoft announced jointly with Docker that they're going to bring the Docker tooling, the Docker ecosystem, over to the Windows Server platform. At that point, Docker could be run in Azure, so you could host a Linux box in Azure, and you could do all of the stuff that you do in the Linux world. But they made a commitment to move all of that tooling so that you could run that off Windows, and more specifically on the Windows Server platform. So we're all kind of familiar with virtualization. Virtualization is, we at some point we realize that we have this hardware sat around not really being utilized, so we can kind of emulate the hardware and expose that to different operating systems and kind of utilize the resources a little bit better. We can, we have a hypervisor and do all that funky stuff, but we're all process, and these processes are small and really fast to boot up, and that's the real key here. All of my containers there will share the host operating system, so it's not like one container is going to run Linux and another container is going to run Windows, but they're all going to share the same base operating system. But they are really, really quick to start up. I don't know how many people have heard of the idea of immutable infrastructure. So this idea that infrastructure is now really cheap and easy to recreate, rather than creating a machine, configuring that over the lifetime of I don't know how many years, and monitoring all of the changes that are going on to that server, where it's really quick just to spin up a new server. And so why don't we just, if something goes wrong with that server, let's just scrap it, we define what that server should look like, and we just spin up another server. And that's the idea with Windows containers. Spinning up a virtual machine, I don't know, at best 10, 15, 20 seconds, 30 seconds, something like that. Spinning up a container, seconds, literally seconds. Right? If it's all, you've got the right hardware, you've got the right setup, literally seconds. Okay, so the idea, no presentation like this is complete without a picture of shipping containers. The ideas come from shipping containers. A week ago, the Windows Server is Technical Preview 5, which came out about a month and a half ago as well. Before that, I've been using Technical Preview 4 for a few months quite well. So things might not work. However, I have prepared, so hopefully it shouldn't affect us too much. If at any point you feel like you're not really learning anything from the talk, feel free to pop out. If you want to jump into another session, I won't feel offended. Okay. I've got my mouse in the right place. Just a little bit about myself. I have been building .NET apps for the last 10 years, right from .NET 1.0, Visual Studio 2002. I'm a full-on Microsoft web developer, Windows platform, never touched Linux in my life. And I suspect a lot of people are like that as well. And so I'm not in the cool club with all the Linux stuff and all that sort of stuff. So that's why I felt like this kind of talk for people who live in that kind of world, what will it mean for you in moving to this new world of new tools and stuff. And what we're doing is we are currently in my workplace. We're not an IT company. We actually sell steel. But we're transitioning from an old IBM system to a new .NET platform. And in that, we're looking at how we can use things like this, like containers, in the delivery of our new software.